So here we have another polynomial function that we want to try to graph. So in the example that we have here, we have a cubic, so that means we're looking for eventually 3 zeros. And so to start off, we use our rational zeros test to identify a list of possible zeros. So that's our P over Q. So here's our P factors are going to be generated from the -6, and then our Q factors are going to be generated from the -1. So again, we're fortunate that we have a 1 as a coefficient. Even if it's negative, that doesn't change much for us. So for our top, it's all the factors of 6. So that's going to be plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. And then in the denominator, it's just plus or minus 1. So effectively, it just ends up being all of the possible factors of 6 are our rational zeros. So for the negatives, it's -6, -3, -2, -1, and then 1, 2, 3, and 6. So now we just have to make a choice and start testing our synthetic division. Now for this one, we have to be careful as we set up our synthetic division. We've got -1 as the coefficient in front of x cubed, but the x squared term is missing, so we're going to need a 0 to hold the place, and then 7, and then -6. If we forget the 0, nothing's going to work properly for us. So we just need to pick a number from our list. So I'll try 2, and fingers crossed that it'll work. So if we start to work our way through this, I bring down the -1, we multiply to get -2, 0 and -2 is -2, 2 times -2 is -4, I get 3 when I add, 2 times 3 is 6, and I have won the lottery again, I get 2 as a 0. So I can go ahead and put that on my list here. I go to 2 along the x-axis, I put a dot there, and again, if I had gotten something other than 0 as a remainder here, I would know that I didn't get a 0, but I would at least know that 2, comma, and then whatever the remainder is, would be a point that my graph would go through. So I at least know that much. But now at this point, because we've gone from a cubic polynomial, we found a 0, which means we found a factor, so that means now these are the coefficients in front of a quadratic. So everything gets knocked down by 1 on the exponents of x. So we don't need to use synthetic division anymore. We can go ahead and now write a quadratic and use our quadratic techniques to solve, whether that's factoring or completing the square or the quadratic formula, whatever applies to the equation that we end up with. So I'm going to have -x squared minus 2x plus 3 equals 0. So this is the equation that we need to solve to find the remaining zeros. So to make my life easier, I'm going to multiply everything by -1. I always like to have a positive coefficient in front of the x squared. So we've got x squared plus 2x minus 3 equals 0. And so now I'm going to try to factor this. So I'm looking for two numbers that multiply to make -3, but add to make 2. So I'm going to need 1 plus and 1 minus. And so my only factor pair for 3 is 1 and 3, and that's going to fit here. I just need the 3 to be positive and the 1 to be negative to make that 2x in the middle. So now I can set each of these equal to 0. And so now if I subtract 3 from both sides and I add 1 to both sides, I get my 2 remaining zeros. I get -3 and +1. So now I can put those on my graph. Go to -3, put a dot. I can go to 1 and put a dot. And so now I'm ready to go ahead and sketch in the graph using my leading coefficient test and the little point plotting to figure out the local maximum and local minimum estimates of those locations. So first of all, my leading coefficient test. I have an odd highest exponent. So according to my leading coefficient test, I'm going to have a disco graph. So that means one side's going to be up and one side's going to be down. But I have to figure out which one is which. So with a negative leading coefficient, if I plug in a positive number for x and I cube it, I'm going to get a positive, but then it gets multiplied by that negative coefficient, so I'm going to get a negative. So that means if I go far enough to the right, my graph is eventually going to take off and go down. And so that means the last time that my graph crosses through the x-axis, which is here at 2, from there on, the graph is only going to be going down. And since we've established that this one's going to be disco, that means on the left-hand side, after it crosses through the x-axis for the last time, from there, the graph has to be going up. So now we just have to fill in the gaps that are in the middle. So one of those numbers we know from the Y-intercept. Remember, the last number that has no x attached to it is always going to be your Y-intercept. So we at least know that the graph is going to go through -6, but I really need to pick the number that's halfway in between my zeros. So halfway in between -3 and 1 is going to be -1. So like we did on the previous example, I'm going to use a little synthetic division with -1, and whatever my remainder is going to be the y-coordinate of my graph. So I need to make sure, again, I use that placeholder for the x squared term. So I've got -1 is the coefficient in front of x cubed, 0 for the x squared, 7, and then -6. And so if we roll through our synthetic division, -1, bring that down, -1 times -1 is 1, 0 and 1 adding, we get 1, -1 once again after multiplying, add and get 6, -1 times 6 is -6, add those and we get -12. So that means our graph goes through the point -1, -12. That's not guaranteed if we were to use a graphing calculator. It's not a guarantee that that is the exact local minimum here, but it's going to be close. And so I'm again going to rescale in the vertical direction here, since I don't want to end up off of my graph, since I have a 10 by 10 grid. So I'll count by 2s. So that means I'm going to have a point at -1, -12. So I go to the left one, and I go down 2, 4, 6, 8, 10, 12. So I'm going to bottom out right there. And then again, we've got this y-intercept of -6, so I can use that here. So I've got this much of my graph finished. And then the last thing I need to do is I need to figure out a rough estimate as to what that local maximum is going to be between 1 and 2. And so our best bet to figure that out, where our graph is going to top out, is going to be to just use a calculator. So I need to plug in 1.5, the halfway point between 1 and 2. So I go 1.5 cubed, multiplied by -1, plus 7 times 1.5, and then -6. And so in the end we get an answer of 1.125. So since we're counting by 2s, we just have a slight little bump here above the x-axis. And so that finishes off our graph. So again, we've got our zeros from synthetic division and then factoring. We use a leading coefficient test to identify it as being a disco graph, and then with the negative leading coefficient, we know it's down on the right and up on the left, and then we plot some points to estimate out what these local minimum and local maximum points are.